Welcome, everyone. Today, we are moving beyond basic AI prompting to master spec-driven development. We will learn how to write a highly structured spec.md file that Claude Code uses as a deterministic blueprint for building entire features flawlessly. Let's get started. Have you ever asked an AI to build a complex feature only to watch it hallucinate or spiral out of control? That happens when we rely on vibe coding improvisational prompting without a plan. Today, we're shifting to a senior engineering mindset. We will learn how to write a spec.md file, a structured markdown document that serves as a deterministic blueprint for Claude. The basics involve front-loading our architectural decisions before writing a single line of code. Why do this? Because LLMs are pattern matchers. By providing a rigid specification, we create absolute boundaries, drastically reducing token waste and architectural drift. In our deep dive, you'll see how a spec transforms Claude from a reactive chatbot into an autonomous software engineer. Take a look at this comparison flowchart. On the top path, we see vibe coding. This unstructured approach leads to high hallucination and messy output because the AI is guessing your intent on the fly. On the bottom green path, we see the spec-driven approach. By establishing clear boundaries up front, we guide the AI directly to predictable, production-ready features. This is the transition from amateur prompting to professional AI engineering. To create our spec, we don't just start typing blindly. We use Claude Code's plan mode. What is it? Plan mode is a read-only state designed for code-based exploration and strategy drafting. The basics are simple. You trigger it by typing /plan or hitting Shift+Tab. Why do we need a separate mode? Because when you're brainstorming, you don't want Claude accidentally creating or modifying your source files. How do you use it? Simply type /plan create a spec for a new feature. For our deep dive, understand that behind the scenes, plan mode utilizes specialized read-only subagents. They safely use tools like grep and glob to analyze your existing architecture, ensuring the spec they help you write perfectly matches your current codebase. This state diagram illustrates how plan mode protects your workflow. You start in the standard interactive chat state, but by typing /plan, you transition into the protected plan mode state. Inside this state, everything is read-only. Claude performs code-based exploration and transitions to draft spec. Only after you are satisfied and exit the mode do you return to the interactive state where code can actually be written. Creating a bulletproof spec requires anticipating edge cases, which humans often forget. Our solution: let Claude interview you. By leveraging tools like Ask User Question, we flip the typical dynamic. The basics: you start with a minimal prompt like, I want to build a user profile page. Interview me to gather the requirements. Why is this so powerful? Because Claude is trained on millions of software projects. It knows what questions to ask about error handling, loading states, and database schemas. How do you do it? Instruct Claude to ask one question at a time until it has enough context to write the spec. In our deep dive, this interactive elicitation process guarantees that your final spec.md covers the non-functional requirements and edge cases that typically cause bugs later in development. Let's trace this interaction with a sequence diagram. The user initiates the process by asking Claude Code to interview them. We then enter an elicitation phase loop. Claude proactively asks questions about edge cases and UI states, and the user provides the details. This loop continues until all architectural gaps are closed. Finally, Claude outputs a robust, highly detailed spec.md file based on the collaborative interview. Now, what actually goes into a great spec.md file? What is it? It's a structured markdown document broken down into clear, actionable sections. The basics require 5 core areas: project overview, MVP scope, data model, UI/UX requirements, and technical architecture. Why this specific structure? Because LLMs process information hierarchically. When you explicitly define a data model, Claude won't hallucinate random database tables. How do you format it? Use standard markdown headers and nested bullet points. Look at the sample code on the slide showing a clear MVP scope using simple markdown. In our deep dive, heavy use of lists and headers optimizes the LLM's attention mechanism. It limits the cognitive load required to understand relationships, allowing Claude to allocate more processing power to actual code generation. This mind map breaks down the anatomy of a perfect spec.md file. From the center root, we branch out into 5 mandatory sections. We have the project overview setting goals, the MVP scope defining what is out of scope to prevent feature creep, the data model detailing schemas, UI and UX handling layouts and error states, and the tech architecture defining APIs and authentication, providing all 5 guarantees of flawless build. We have our spec, but we cannot start coding yet. We must execute the handoff. What is this? It's the critical step of clearing the conversation history before code generation begins. The basics: you exit plan mode, ensure your spec.md is saved, and run the /clear command to start a fresh session. Why is this mandatory? Planning conversations are filled with discarded ideas, brainstorming noise, and massive file reads. If you code in that same session, you suffer from context rot. How do you execute the handoff? Run /clear, then simply prompt, implement the feature exactly as described in its spec.md. Our deep dive reveals that LLM context windows degrade as they fill up. By starting fresh, your system prompt, your project rules, and your spec.md become the sole focus of the model, ensuring laser-like precision. Observe the handoff flow. We draft the spec.md in plan mode, then save it to disk. Now look at the critical red node. We run the /clear command. This severs the messy past from the future. We enter a fresh session context, leading to the green execution node where we prompt Claude to implement the spec. This single step is the difference between buggy code and production-ready features. Once you hand off the spec, Claude Code leverages it for subagent orchestration. What does this mean? Claude uses your spec to guide specialized subagents to do the actual work. The basics: Claude reads the spec.md and breaks the implementation down into a managed task list. Why is this amazing? Because a massive full-stack feature would overwhelm a single prompt. How does it work? Claude automatically utilizes the task create tool and spawns subagents, perhaps assigning the database work to a backend agent and the UI to a front-end agent. In our deep dive, we see that when a spec clearly delineates front-end versus back-end requirements, Claude's internal orchestration engine can efficiently delegate these tasks in parallel, completely automating complex, multi-file software engineering without you having to micromanage the steps. This architecture diagram shows how Claude acts as a tech lead. The fresh Claude session reads the spec.md and hits the task orchestration decision node. From there, it splits the work. It uses task create to spawn a front-end subagent to handle UI components and styling, while simultaneously spawning a back-end subagent to handle API routes and the database. The spec acts as the unifier, keeping both agents aligned. Let's look at a real-time, highly impactful use case: building Hook Hub, an open-source hook marketplace. The scenario: we need an MVP application to display Claude hooks in a grid. The planning phase: we enter plan mode and ask Claude to write an initial spec. Claude uses the Ask User Question tool to interview us about the data source like GitHub repos and the required UI fields. The spec is generated and saved as spec/claude.md, detailing the UI and next.js architecture. The execution phase: we run /clear for a fresh context window. Then we prompt, implement the main page grid as specified in its spec/claude.md. The value delivered: Claude flawlessly generates the components, layout, and styling in one shot because the boundaries were entirely predefined. It saves hours of debugging and prevents endless back-and-forth prompting. Let's map the Hook Hub journey. In the planning phase, the user runs /plan, Claude conducts an interview to gather context, and then generates the spec/claude.md file. Notice the clear break before the execution phase. The user clears the session context, then triggers the implementation. Claude reads the spec and generates the next.js components perfectly on the first try, leading directly to user approval and deployment. Let's wrap up with governance and best practices for spec-driven development. First, keep your specs modular. If a spec grows beyond 200 lines, break it into smaller files and reference them using the @ symbol. Second, treat specs as living documents. If requirements change mid-project, update the spec.md file first, not the code. Third, combine this with your project's claude.md file. Your claude.md dictates global project rules like coding standards, while the spec.md dictates the specific feature logic. Master this separation of concerns, and you will transform Claude from a simple coding assistant into a reliable, autonomous engineering partner. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final diagram shows the continuous governance loop. The global claude.md feeds project rules into Claude's context, while the feature spec.md feeds the specific feature logic. This combined context drives autonomous code generation, which leads to code review and tests. If changes are needed, the loop flows back to update the spec first, ensuring your documentation and code remain permanently synchronized.